Hello, everybody. Welcome to Robot Builders Night Virtual with Dallas Personal Robotics Group. Today is the 11th of July, and we're going to do the usual and just walk around the table. Try and focus on things related to robots, but we often go off onto fun tangents. So we have a queue tonight with this in line: Mike, Doug, Scott, Ray, Pat, myself, then Harold. So everyone's got a little something to say, pretty much. So with that, I'm going to stop sharing. And so Mike, what do you got? ESP boards.
Yeah. So I'm just out of surgery from yesterday, so I was looking for a project to work on. And so I might not be able to sit too long tonight. But I have this other project I've been working on. One is a lighting project for smart bulb control. And then there's a new technology or protocol called Matter, M-A-T-T-E-R. And it has much more promise than what I was doing. So I'm thinking of redoing the project. And that drove me into the ESP32 spectrum, because they seem to be well integrated into that technology, new protocol for smart homes. I'm not doing it for smart homes, I'm doing it for theater, but I wanted to use smart bulbs in the theater. And so I noticed that they had a new ESP board, a ESP C6 and an H2. And the C6s are relatively easy to get. And I tried to integrate it into the ESP IDF. It's the most recent version one that finally came out last week. And I tried to integrate it into the Eclipse IDE and the VS Code IDE. And I think I like the VS Code IDE better. But I'm just having a hard time getting the debugger to work. The debugger is built onto these new boards. I was wondering if anybody had any experience with the newer ESP boards. Okay.
Yeah, I've had some experience with the ESP boards, but I've been using the Arduino IDE. Occasionally, I use Platform IO to look at different files because it's quick, and I like the formatting, and I can find stuff really quick. And but haven't used the debugger, or I know some of the boards have either debug capability built in, or you can attach to certain pins and with another board, but I haven't done any of that.
I've got the Blink program to run, and I've gotten it to debug once, but something happened and now it doesn't run, it doesn't make anymore, it doesn't compile. So someday I'll figure it out, I guess.
You're leading edge there, Mike. I don't know if anybody else has played around with ESP32s, so.
Yeah. And
well, the compiler, I wouldn't think the compiler would have any impact on the debugger. I mean, those are two separate processes, right? So when you were compiling it originally, is there an application on your PC, or were you doing a cross-platform compile and compiling it on the ESP? Because I'm not familiar with the ESP boards.
Well, I'm using the ESP IDF inside of Visual Code, which is Visual Studio Code, and to give me an IDE, and it uses the GCC compiler, the Ming W64, and it uses OpenCD debugger. So it's all supposed to work, and I've seen it work once or twice, but I just reliably can't get them working. I was thinking of uninstalling it all and restarting it, and because somehow I kill it. Kill it from the perspective.
Yeah, some setting in either deep in Visual Code or in the platform itself that you're missing. So yeah. Some of those I use Visual Studios with a GDB plugin, and it's really nice because I love the editor in Visual Studios. but getting the environment set up was quite tricky because you had to manually configure all the load files and all that, which you shouldn't be doing, using the ESPs. But
yeah, because I'm using the ESP plugin.
Yeah.
But it's really complicated, like you said. I was hoping ESP would do it all reliably, but it looks like it's fragile.
Well, a lot of times under the project settings, you can open up the project settings and project options. And under the compiler and linker, you can kind of see what's in there. A lot of the trouble I had with it is getting the paths, like the system paths, to any kind of include files or libraries configured within that project.
Right. Yeah, it lost the path to the CMake, which is what it uses to make stuff. And I found the path again and got that working again. Oh well, that's going to be a journey. I thought it'd be easy.
It's not supposed to be easy.
Supposed to spend my time designing, not making it work, not making the tools work.
What's your impression of this Matter protocol?
I like it. I think I can. I like the Philips Hue bulbs, but I don't like to control them at the Zigbee level. And so I'm hoping to use. It has the hope of using the Philips Hue controller, the bridge, and I can use that to set up the bulbs and keep them in maintenance, and then have another program that uses Matter to get access to all of the Philips Hue bulbs, and that's supposed to come out sometime this quarter, I think. So I'm way ahead of the curve. but the Matter technology just came out last October, November, December, and this microcontroller can do. It understands Matter a lot, and Matter can control smart bulbs that are Wi-Fi or using Thread. And this one has both radio engines in it, this particular processor. But I'm hoping I can just go and use the Hue hub and the other hubs from different vendors for their bulbs, and take away lots of levels of complexity, like over-the-air updating of the bulbs and stuff, and take it out of my code and use their stuff. So I'm hoping to just take a lot of stuff out of my project that I've been working on that hasn't been working well and stick it on someone else. So I'm hoping that Matter is going to do that for me.
So, Mike, you don't want to be the man behind the curtain, pulling the levers and flipping knife switches and that kind of stuff, Because opening and closing the curtain,
Oh yeah, it's
like that.
Real pain. Yeah. But one thing on the C6 board, it has a can't remember the name. A Pixie LED. It has the two-wire interface for a string of LEDs, and it's only one LED, so it has that protocol.
Oh, NeoPixel.
NeoPixel, yeah. I think it's that protocol, but it's only one LED on the board, RGB. And when I ran my code and got it running, I noticed that it was just a quick flash instead of 1 second on, 1 second off. And I pulled out the scope and looked at it, and it looked okay, but one pulse might be a little too short. And then I started changing the amount of time the bulb's supposed to be on and off, or not the bulb on and off, but the intensity, like 0 to 255. And it was set to 32. And it was flashing. When I brought it down to 8, it came on for a second, came off for a second. So I don't know what's going on with that, but so the darn thing works, but weird stuff's going on. Of course, the demo I see on the videos and stuff, the bulb's on and off. But Oh, so at least I'm not bored. Frustrated, but not bored. So that's my project, and hopefully I can use ESPs on some robotic projects.
Yeah, they're pretty capable little processors, so
Yeah.
sounds like a good warm-up project.
Yeah.
I still have hope to make one of Ray's chick magnets.
Oh, yeah.
Yeah, I've got it's an ESP32 too. I got the board that he recommended, and sooner or later I'll get to it, but there's some things in front of it.
There it is right there.
I need to put like a 5 or 6 inch LCD on it, touchscreen LCD.
Yeah, this one's
Yeah.
pretty nice. It's a touch screen and capacitive touch.
Need to get a transparent LCD.
That'd be cool.
Yeah.
I'm actually looking at maybe not LCD, but using paper, e-ink. But oh well. So whatever I can get.
Yeah. Cool. All right. Thanks. I think, Doug, you are next.
Yeah.
What's
Okay.
up?
Well, unfortunately, the lead off thing I was going to show you guys is gone, but I thought that let's see, how do I share here? Sit now. Yeah, but anyway, the one of the things I was going to show you guys was this. They had them up for $99 again, and when the meeting started, there were still 2.
Oh,
Anyway, that's finished.
and
Now-
now there's none, huh?
Yeah, I'm going to work up to these things. First of all, one of the things that I talked about last week was, well, does 360 for makers have CAM? And yes, it does have CAM. And I found this this particular tutorial on YouTube, which I would say is standout. He essentially makes this box and he takes you through it step by step, and very good. And it would be something that I would recommend.
Is that for milling or for 3D printing?
A milling.
Oh, okay.
Okay. And I'm trying to flip this all around. And I also, I was listening to Mike talk. He's using FreeCAD almost extensively, and I told him I never could get my mind over it because I didn't understand how they were trying to do it. And I found this tutorial, which is really, really good and explains what they're doing. And I now understand how they're doing it, instead of just kind of like, in a lot of CAD programs, you just draw things and add them and add them and add them. Well, on theirs, every time you add something, you essentially have 2 constraints, a vertical constraint and a horizontal constraint and a Z constraint, I guess 3 things. And you have to set those before you can move on. And that was the reason why I couldn't figure out what the heck I never could get over the initial hump of how do you build something with this stuff. Let's see, he's got put.
I used FreeCAD too, with just primitives, adding and subtracting.
Yeah, so he gets, I don't want to, but anyway, he gets through it. I was going to try to find a picture. Oh, there it is. This is what he builds in this particular tutorial. And like I say, I'm not saying I would use FreeCAD, but at least I now understand. I think I could use it. Before, I never could get my teeth around exactly how to do it. So let's see if I can put that. So that's one thing that, so those are another 2 tutorials that I found on our week off that were just really top notch. One on CAM with 360 and one on how to use FreeCAD. Now, so what I want to do now is talk about my main thing here. I took my little 3D CNC router, which is pretty good for woodwork, and I've replaced the original Z-axis on it, and I want to show you this. I'm getting a black star for this, guys, because this one was a bummer. I mean, well, let me put it this way: it was harder than it looks. So here's what it looks like now. So here's the it's a I think it's a 500 watt spindle, and it's all metal here, no plastic. This particular 3018 is really a 1830, and so the x-axis is the short axis, as opposed to a lot of them which have the x-axis as being the y. But the big thing on it is not only is it shorter to make it more rigid, it's got instead of 10 millimeter rails, it's got 12 millimeter rails. So it is quite more, a lot more beefy. Unfortunately, I don't believe it's available anymore. And then over here, this is my controller box that I made so that I can, let's see here. I think I can do it. Okay. So you can see there's the spindle working, and so the way this, I was going to show you a little bit of this. Let me get it going here. Sorry for trying to, the heck? Oh, here it is. I'm sure I just made you all seasick. Yeah, anyway, so here we go. I got it plugged in, and now you can see, here's an example of a, let's see, reset. Oh, wait a minute, gotta turn it on. Reset. Well, damn. I want to take this.
So what GUI is this from?
This is Candle.
Oh, okay.
And let's see, open, see, oops.
Yeah, having just assembled one of these in the last week, I recognize all that stuff, Doug. Good job.
Yeah. And
My motor doesn't make near the beefy sound yours does.
yeah, well, if you look at the original spindle, you can see it's a 75 watt spindle. It's surprisingly good. Now, I did find one thing that you have to do, and this is a trick that I haven't found on the internet, but it was, just typical robot stuff. You can see I have 0.1 microfarad capacitors between the plus and minus and between the body and each pole. And that cuts the noise off of the built-in spindle way down. Before that, I would get an occasional skip. But now with those capacitors, it doesn't do that. Okay. Reset.
I think I have some of those just lying around, as pretty much probably does everybody on this call.
Yeah. Yeah, I don't know why. I can't seem to get it to sound. It's probably. I don't know why my whole computer seems to be bogging down.
So,
Let's see.
Doug, where did you get the replacement spindle from?
I mean, that's mainly from Amazon, different parts. You know.
If you do a little, if you go looking for those sorts of things, before you know it, those spindle ads will be showing up in all kinds of places. Like
Yeah. Now I had to. It comes with this, and I don't. It's in here. There's a power supply, but so I went and added some better switches and stuff, and you can see the power supply in there because you would kill yourself eventually if you left it exposed. So I have up here a 2-position switch, which eventually I'll have over here where I take my controller board and actually use a relay so that I can control it directly from Candle.
they say you can make Lightburn do all this stuff too, but I haven't played with it yet.
Yeah, I use Lightburn for my there it's now it should be.
I've been immersed in some of this laser stuff and stuff the last couple of weeks. So
okay, so I'm going to send it now. So if you're looking at my camera, you can see it doing all of its little CNC stuff. It's going to draw. It would essentially do this, but goes ups and down. And the real tricky part with adding this was having to add the end stops back in. So these are 3D printed brackets that I had to design to bring in the different end stops. So anyway, you can see it there whirling and wiggling. And so I don't think we need any more of that. So that was what I wanted to show. Get back. Oh, wait a minute. No, there was another thing. A member of our club, he's not a member right now, David Wilson, I believe, is leaving the area, and he's had some things that he might either want to give away or sell, and he asked us to talk about it. I don't know, is this a good time, Carl?
Sure.
Okay.
Yeah, we're not.
All right. So let's see where. Okay, give me a second here. All right. So these are some things. Here's the action: sell or donate. So if you're interested in any of these items, I'll give you. I won't. I'll ask Carl to stop the recording, and I'll give out an email address. Okay. So
just a moment. It's let me see. That's
I'm not sure.
Oh, are we going to ask if anyone's interested first?
Yeah, let's go through the interest then. Yeah, that's all right. So I'm not sure. This looks like just looks like a little inexpensive multimeter. And this is a battery charger. I don't know much about it, but he used it for his bench top. This is a laser particle counter, which that would be if somebody who wanted to do a specific project, I imagine. This other item was a HP11C. I don't know what that is, but
Calculator?
Calculator.
is it a calculator? So anyway, it looks like it's a bunch of other old. It looks like old iPhones, but
Yep.
and then this one is electric components and crafting tools. So there might be something there. This is a. It looks like a scale, maybe.
Yeah.
And I think this is just high impact foam. I'm not sure of that. CO2 meter. This is a BK Precision DC regulated power supply. So that's probably pretty nice, but I think he wants to sell that. But, if you don't have a power supply, if you had, that's the first thing that you want is a good bench power supply. So if you don't have one, this might be worth looking at. And it looks like you got into some of the conductive thread stuff. So it looks like he has some stuff there. Okay, and this is make block aluminum. I can see the make block over here. I see some cones. I don't know what this is right here, but I believe he said he had a lot of make block stuff. So this is probably make block stuff. So I thought, Ray, I thought of you when I saw this.
Mm.
And I don't know.
Yeah. Do you have any idea what would be in the make block box?
Well, he said that he got it from when Make Block was on Kickstarter.
Oh.
All right. So I don't know what's in there, but you can give him a call and ask for additional detail.
Oh.
All right. Now, this one here, this would be the one that would interest me, though I can't, I have to fight my hoarder instincts. Looks like he has a lot of DC motors. It has wire, some wheels over here. And this looks like microcontroller boards in this area. So this one might be something worth, and he's got it as a donate trash. So if you're interested in this, that'd be something that you could take. So I think those are what he had. If you're, and I want to say that the person is, I can't recall exactly where the person's located. So, but it's not, for me, it'd be about like going to the maker space, I believe. So anyway, I throw that out. He asked if there's any interest, please contact him personally. And I'm going to ask Carl to take it off the record if he can.
Okay, are you doing voice? Yeah, if you do voice and text in the chat, then we can delete it from the chat and I can mute your voice.
Okay, give me a second here. Let me find. some milled aluminum parts. So that's where I'm going with this. And that's it. That's what I had.
Cool. Thank you, Doug. Hey, I should ask while you're on the line. So we received an email, or some of the club emails received an email from, was it Museum of Flight, Moon Day
Oh, yeah.
on the 22nd. I'm not interested to do it, but do you know, is anyone in the club? So traditionally, or very often in the past before COVID, DPRG would set up a table and just show off our favorite robots and stuff down on this Moon Day celebration at Museum of Flight by Love Field. And I think Kareem is Iron Rain's gonna be there, right? So
yeah, we're gonna be there.
I'm probably not able to go, but is there any interest in the Dallas members to do any of that this year?
It was right up until my tree guy to cut down a bunch of trees scheduled on that same date. So.
Oh no. Okay.
Yeah. Unfortunately, I have out-of-town guests coming in that day, or I'd be there. Because it is a lot of fun, guys. And
Is it July 21st?
yeah.
Yes, this month.
So I think we're
Well,
gonna
that's
have
my
to.
birthday, so I can't go.
Get back, Ray. Get back. Okay. Well, so
Yeah, it was always kind of disappointing. I think it's kind of a lot of
It's
work.
actually
to
the
set it up, and I
5th.
think
It's
we always
this
try to
Saturday,
get-
I think.
Oh.
It's this Saturday.
Isn't
June.
it the 15th?
That's
Oh, I don't know.
No, we're in July, right? I think. I'm pretty sure we're in July.
Yeah,
At least for another few days.
Yeah.
yeah. Right, it's the 11th.
It might be the 22nd. It's either the 15th or the 22nd, but
I think he said
it's the 22nd. It's the 22nd. Yeah.
That's over the 15th. I might kind of push some of you guys to let's go do it. Let's go.
Oh, this guy named Kareem sent it. So it is the 22nd.
It's the 22nd. Yeah.
Yeah.
22nd, okay. Okay, it's the day after my birthday.
Yeah.
Yeah, it seemed like we always tried to get, more members to join, and it was a useless effort. I don't think it ever got any new members to join, so it's kind of like, meh.
No, it's a really long-term thing because it's really you're talking with families of young kids mostly, so it's more along those lines.
Well, I liked it because of all of the it's one of the easiest ones to set up for. It's one day, a few hours. It's pretty well organized. Not always organized, but usually it's pretty well. And you can have a few things. You can have like an Xbox 360. You can have a couple of robots demonstrating. It's very easy to set up for and have a lot of fun with. But like I said,
and diverse people.
Yeah, and it is giving back a little bit. So
Kareem, do you think the payback would be in our lifetime? The little kids see it and think, oh yeah, the DPRG.
It would be the more.
It's really cheesy, but the reason I'm into all of that kind of stuff with teaching the younger kids is not about payback for me. It's just about feeding it forward. So
Oh, okay.
I agree with you, Kareem. I'm kind of like that too. I used to like the one that we used to do in Fort Worth too. I don't know what.
Yeah,
museum.
They had a science museum there.
Yeah.
Science or what? I don't know.
And we did actually make some contacts and spread the word about the club. And I want to say that I'm not sure how that's something one of these days we're going to have to shake off the COVID, and we're going to have to figure out how do we keep the club going? Because if you look at these guys, you're looking a little gray to me, dudes. You know, we need to find some people who can bring some new life to the club. And you know, like our Putin, our president, who's lifetime president. That's not the way it's supposed to be. And we need to figure it out how to move beyond that. I mean, I don't mind this type of format, but the other type also brings a lot once you actually force yourself to go do it. It's a lot of fun. So anyway.
Yeah, I don't know. I kind of like the Tuesday, video conference. It saves me a 2-hour drive, and
yeah, I understand that.
We could, I think the once a month meeting might be good to resurrect.
Yeah,
but,
yeah.
I would tend to agree with you on that, Ray, because it benefits you get a hybrid then going.
Yeah.
Yeah.
I drive 2 hours to get there.
You would?
You gotta remember, he has to drive 2 hours to work.
Or longer, probably.
Across town.
Or longer, probably.
Across the whole Canadian.
Yeah, I think Pat. What is it? When you travel, you go all the way up to the deep north, don't you?
Well, I'm to drive here was 36 hours of driving.
Whoa. Whoa.
So, in Canada and the U.S., they're big. You got to cross the country.
That, or else you'd probably take your camper with you when you do it, right? And stay there for a couple of days.
Oh yeah.
Yeah.
So
well, you're in your camper now, right?
My fuel budget was $3,600. So, gas isn't cheap here, but hey, let's go back to it though. I really enjoy the Tuesday meetings. Well, I'm trying to make it there. I'm hoping to be able to make it there in November for podcast.
Yeah.
That'll all be determined if I can get parts and get ready and see how we go. But I'd like to see these continue, even like if you guys say do a once a monthly meeting at Makerspace in a hybrid format would be great if you could do it. But otherwise, I'd like to see a Tuesday meeting.
Well, I'd like to, because there's a lot of topics that I really learned a lot from people that were sharing their information. Iron Rain has shared a lot of things. I've learned a lot. Scott showed us a couple of presentations that I really, really, really got a lot out of. Maybe one more of those canned ones, and I might finally figure it out to use it. But it's very enlightening. So I mean, maybe that's the way we step into it, Ray. We go ahead and start up get a schedule for monthly meetings. I mean,
so speaking of topics that we could discuss or so, I have one, since I don't know what order we're running in.
Basically, John, we have, when Doug's done, we have Scott, Ray, Pat. I have a little distraction, Harold, and then you would tack in.
Okay.
Am I the distraction? Is that what you said? That's what I heard.
Oh, no, I didn't mean it that way. I'm a distraction because I haven't had.
I can distract, man. That's part of my superpower. I can procrastinate anybody, and I can certainly distract them.
If you'd like,
use that power for good, though.
Excellent. I think that's our segue then. So, Scott, are you going to get us back on track?
Well, I hope so. But first of all, Doug, I got to tell you, there's nothing wrong with gray hair.
No.
I mean, it's losing it that's the problem.
Hey,
at least you have enough of it.
Like I say, me and Carl got some issues with there's nothing wrong with gray hair.
Yeah.
Hair.
I'd go with any color at this point.
Yeah.
So anyway, I've been doing a lot of work on time of flights here lately. There's a project at work with a sensor project. So there's accelerometers and barometers, and one of them is a time of flight. And this is one of the boards.
There you go. Okay.
It's got a little ST32 on it, and you can see the time of flight there.
Mm-hmm.
That's where the accelerometer is and the barometer, which I'm not using. But I've been able to basically take because this is all three of them run on I2C bus on different buses. So what I was able to do is there's another board that's in that system. It's got a little bit bigger ST32 on it. It's got one of the H's in it. I think it runs at like 480 megahertz. So it's a
Probably
beast.
the H7.
I have about 24 of these boards that were scrapped out. So I'm trying to figure out what I can do with them. They also have radios on them, little low-ran radio modules that I have 100 of. So hopefully I can utilize those at some point too. Those are, you basically write your own code into the radio itself. So basically the radio is, like a peripheral on it. So that's an interesting chip. But so then I thought, you can never get ready too soon for another contest. So one of the problems I had with Turd was the sonars. I was using the same crappy sonars I had on Burp. So I thought, well, let me see if I can use these time of flights and, replace the sonar. So that's what I did. Let me see if I... So anyway, I got...
And they work outside?
Yeah. Yeah, they work in direct sunlight just really well. So I took those modules and I 3D printed a little bracket for them so that I can mount them into actually you can kind of see because this is active, you can actually see the laser in there a little bit.
Yep.
And I also got it set up, this board had a bunch of LEDs on it, so I've got it set up that if you get too close to one, that the light starts blinking red instead of green. So this is what's going to be on Turd this October. And then I think I got this. This is another LiDAR sensor. It's CAN based. I think I got it as one of the contest prizes. So that's where I've got 5 sensors. So I've got the center sensor, which is going to be the CAN based one. And then you've got the 2 left and 2 right sensors.
It's useless.
It's going to, help keep it from running into something, hopefully. But like I said, it's been a really interesting experience to learn about the time of flights, and these have the ST time of flights on them. So you're using the ST's HAL library for it, and which of course it was already written and configured when I got the code, because it was actually developed by a team in Spain. So anyway, that's kind of what I've been working on, and where Turd's going. Still working on belts, trying to get the AI to work. Really struggling with the model training. I found I forget the terminology. Basically, the picture library for a set of traffic cones, kind of like what you were doing, Doug.
Mm-hmm.
But then I got to the stage where you have to basically compile or / train the model for your interface. And so that's where I'm struggling to figure out how that works, and actually how to load it into the OD. Because you were saying, Doug, you were using Python, and of course I'm using their C++ library.
Mm-hmm.
Finally got it all working as far as the API and being able to access the camera and the stream, and get the coordinates from the data and all that. But I'm just using the default library. So now I'm to the point where I'm trying to plug in one with the traffic cones in it.
Mm-hmm. God.
But then I got sidetracked on this as a distraction, so that I wouldn't have to mess with it. But I still got to get back to it at one point. It's not going away.
I wanted to ask you some questions about your time of flight stuff. Are those the ones that have the array on it, the array of sensors?
Yeah, this is basically ST's baseline time of flight. They got different levels with different capabilities. And this is what they have, what they call a spade array, which is single photon avalanche diodes.
Mm-hmm.
And this one has a 16 by 16 array.
Mm-hmm.
And that was one of the things I was investigating at work, because we're mounting this on the door of an elevator and we're measuring how, the door opening, or we're determining whether the doors are opened or closed on the elevator based on the time of flight sensor. So my task was to investigate changing what they call the ROI, or the region of interest, by defining, the different spade array sizes.
Mm-hmm.
So that's where I got involved in this project, to do that research. And so basically I just thought, well, shit, I could use this for a robot.
Yeah.
And I got a whole box of them that they were going to scrap. So I said, no, send them to me and I'll build a robot out of them. And so that's what I'm working on doing.
Okay. Well, let me ask you this. What's your range on those?
These actually have, there's a register setting. Of course, it's all done through API, for what they call short, medium, and long range. But to them, long range is like 3 meter.
3 meters.
So that's probably, and of course I think outside, in the bright sunlight, you may lose some of that. I really hadn't played with it, in a larger environment, because we're working very constrained, right? There's a lot of moving parts and hardware really close to where we're mounting it, at work.
I don't know if it's the same chip or not, but I just got in my hot little hands the Pimoroni version of that, which is an 8x8 matrix. And I was doing the reading on the data sheet. And yeah, it still got the same kind of thing, anywhere from about 3 centimeters up to about 4 meters, depending upon how fast you're reading and how much resolution you care about. It's really constrained. Right. There's a constraint there.
It's kind of a trade-off.
Yeah.
So at say 3 meters, Scott, what is the field? Is it, since it's a SPAD, it should have some sort of angle, right?
Well, yeah, and ST is really not very good about defining that in the data sheets, because I poured over these things. They recommend a 38-degree cone of clearance. So they kind of suggest, and now you have to remember that this isn't just a single light beam going out, right? There's actually 2 arrays. So there's a transmit array, and then there's the reflect array. Mm-hmm. And each spade diode in that array has its own time, right? So they're pulsed through the array. Mm-hmm. And what it actually does is it takes an average of each one of those, because that's one of the experiments that I was doing was, clipping the edges of that field. But we were never able to really calculate directly what the actual field was. We just calculated as a linear progression, because if a 16 by 16 array was 38 degrees, then 8 by 8 is going to be half of that, right? Mm-hmm. So we made that assumption, but that may not necessarily be accurate.
Okay. So what about refresh rate?
We're running at 400 hertz, something like that. So it's pretty damn. Well, the way it's set up on this platform here is it's driven by interrupt. So you tell the API, okay, clear the interrupt and start a new sample. And as soon as the sample's ready, you get an interrupt trigger on just a GPIO line. Mm-hmm. And even running 4 sensors here, of course, they're all on different I2C buses. So, they're all running. I really hadn't calculated these, but at work, we actually limit it to 400 hertz because that was the data cycle that we needed. So if it's capable of doing more than that, I don't know. I'd have to look. Yeah. But that's still pretty damn good.
That's really good. If you're getting 400 readings per second, Now, is that individual diodes or is that the whole SPAD array?
Now that you don't really have access to individual diodes.
Okay.
That you basically get an amalgamated reading of the average.
Okay.
Because what I did is I took like a circle and then a known target, right? So as you move the circle back and forth around the cone, you actually change the reading, right? So you aren't looking at like a maximum reading of that spade array. You were looking at the average. And that actually really messed things up because you can get what they call crosstalk. Because again, you're pulsing a laser out and then you're reflecting it back, and you're measuring that amount of time within that frequency range, right? So you have these windows, and you actually get error codes. Like if you get out of a window, like if you get crosstalk, you'll start getting an error because you read one spade array read something out of phase, they call it. So, it's a different environment, basically, in an open room environment versus the application that I was trying to tune it for. So I haven't really looked at, I just got this working this weekend altogether. So, I'm still kind of playing with it. Now I'm trying to get them mounted, in a range because, the angle that you mount the 5 different sensors, really needs to be representative of what its field of vision really is. So that's the kind of thing I'm trying to figure. Actually, I'm thinking about just reusing the sensor array that I took off of the burp. So we'll see how it goes, and then I'll tune, the ROI based on, just playing with it, really. So, but I really like the time of flights. They're really accurate. We get these within, the resolution on this sensor claims to be 1 millimeter. But since it averages out the reading, you never get a truly accurate, reading of how far it is to an object, because you're always having average, ones that are bouncing off like the table or some other object in that area. But for obstacle avoidance, you really don't care if it's exactly 22 inches or 22 and a half. You just don't want to get any closer than 0, right? So I think that'll help. That, like I said, that was one of the challenges at work, is we were trying to actually get an accurate measurement out of it, which turned out to be very difficult to do. So.
Yeah, I'd like to see, because the ones I've been playing with, the ones from Pololu, they have a maximum of about, I think it's a little over a meter. 1.3 meters or something like that, 4 feet. So, which outdoors might be okay, but since my robot, it'll depend, because this year it's going to be a differential robot, so I can control the speed a little better. We'll see how that goes.
These we have set up at the mid-range, which is, I think, a maximum of like 1.5 meters. So you're talking, 5 feet or so, 5-6 feet. And I'll probably leave it there even for outdoor, because, one thing I found with the sonar is you get too much information, right? You start getting these false trips of something that's 10 feet away. Well, you don't really, unless you're doing, 20 miles an hour, you don't need to worry about something 10 feet away, right? At our speeds, you don't really need to worry about anything that's more than about 5 feet away. And, the other thing I've noticed is even, if you're driving past something, it can be very close to you, right? Because you're going to just drive right past it, 6 inches away from your wheel. And to me, I found that that's a lot more difficult scenario than just something dead ahead that, okay, I've got to turn, and drive around it. You know, how do you go down somewhere fairly narrow, you know, without bouncing back and forth trying to, you know, feel your way? That seems to be the much more difficult. And I love the time of flights because there's so much more, even though you have, you know, that cone, you can control it, and B, it's much more concise than the sonar. Plus, since it's light waves instead of sound, your reading frequency goes way up too. You couldn't get 400 hertz out of a sonar, right? I mean, sound is not going to travel that far.
No.
Scott, you got a part number for the ST device used in those modules, or?
Give me a minute. It's either VL53 L1X or something. Let me look it up.
Scott, can you put it in the chat?
Yeah. That's
Yeah, I remember the one that I remember was actually like an 8x8 array, and I think they said the diagonal measure was like, it was kind of weird, but I want to say they said like 60 degrees for the whole array, and that's quite broad. And I kind of hope it would be a lot less than that, but.
Yeah, you know, like I said, we never really quantified it. That wasn't really our objective too much. But I mean, it's you know, a 30-degree cone is probably not unrealistic. So you know, you have to do the math on, you know, depending on what your distance is. So you know, if you're limiting the overall distance, then your cone is going to be smaller. So here's the, like it said, it's the L1. I think they're up to like the L5 now, where they have a lot more like AI. Like I think the A5 has a like a people detector in it. So there's more interface in the API. You look up a data sheet on this thing and it doesn't give you the registers. So you really have to kind of use the API that ST gives you to and their documentation on the API as far as how to configure it, and what the capabilities are and how to use it, you know, what it can do. But I think there's another one, I think that's a 64 by 64 array.
Wow.
So I think that's part of their 3D, because, you know, the one I'm using on belts now is like 160 by 180. And sifting through that data was a challenge. You know, I'm still trying to learn, you know, how to utilize all that data. So. Pat, you said you had a question?
No, I think it was Ray.
Oh, was it Ray?
Yeah, you answered. I just want to know what the part number was.
Scott, have you had any luck with in sunlight with those sensors?
Yeah. Yeah, I mean, I've run belts with the one I have on it outdoors and don't have any trouble with it. We did tests at work and, you know, like glass back hatches and, you know, with sunlight coming through, you know, glass wall or atrium type of scenario. We didn't see any. We had big, powerful, you know, LED flashlights right in them. And we don't have any kind of optic filter on it. It's just a clear glass lens that it looks through. So, hadn't seen any of that yet. The early IR stuff that we were using, like when we were having contests down at Fair Park, they had the bank of windows and the sunlight would come through there and it would screw up an IR sensor in a heartbeat. But these spade arrays, these avalanche diodes, that's a much higher frequency light. So, we hadn't seen any of that.
Okay, I'm curious because they're available for really cheap. The sensors.
Well, the real trick is, because I played with some a couple of years ago. I think I won them in one of the contests, where they had, put a microcontroller in front of it, so that you didn't have to deal with the intricacies of, the API. And, the API is not a trivial thing. I'm glad I didn't have to figure it out. But I didn't, I really had problems with making them reliable, and their interface was really screwy. It's supposed to be I2C, but it violated some of the I2C stuff that the micro I was using didn't like. So I gave up on them. But still had some, when they were working, I really liked the accuracy of the data. So that's why when I had, started working with these, I was like, man, I can do something with this. And now I got a whole box of scrapped out stuff, so I got to do something with it.
Cool. All right. Let's see. I think next we had Ray, then Pat, Harold, John. I moved myself to the end because it's really not robot-y, but it might be fun to the audience. So I think Ray, what you got?
Okay. So I've kind of gone on the CNC journey myself here recently. Basically I had a large washer, I don't know, maybe probably 4 inches in diameter. I wanted to bolt a hydraulic motor to it. So I had to drill, and it's steel. It's like 1/8 of an inch thick. I had to drill 4 holes in it. So I put it on my, my little mini CNC machine that I was using to mill aluminum parts. And basically I wanted to use it to position it accurately and just disconnect the Z-axis or loosen up the 2 set screws that force the Z-axis to go up and down, and just make a little tick mark of where that location was and then move it to the next location. So it would be positioned fairly accurately, so it would line up with the holes that are on the hydraulic motor. So it's kind of like they say, holding the workpiece is everything. And I was kind of in a hurry, so instead of having like the hold downs, you either want them pressing down, you never want them like at this angle on the piece. You always want it at least flat or pressing down on a point. And in the process of tightening it up, it actually moved the piece over a little bit. So right from the start, I was screwed. It wasn't going to line up with where I wanted these holes, because this is just a large washer, and there's a kind of a boss on the pump that this washer had to fit over. So drilled the first hole, went over to where the second hole was supposed to be, and realized that it's definitely off. So I look underneath, and sure enough, the washer had been pushed over by one of the hold downs by about 5/16, 3/8 of an inch or so. And so I repositioned it, drilled the 2 holes, then went to try to go to the other 2 holes. And I was using some fixturing from milling the machining part, or the aluminum parts. And I basically hit an end stop before I could get to the holes. So it wasn't going to be, I couldn't use it to do the other 2 holes. So basically took that off, made a paper template, punched 2 holes, or punched 2 tick marks in the thing, and just drilled the holes by hand, and it was close enough. It all worked out. But it's like, some of those things for that one-off thing that you need to machine, it takes forever to set it up, and you may not be able to finish, doing what you're trying to do. The other thing is, we had a really bad storm out here. I think a lightning strike hit our metal building and it wiped out our security system. I had been using these little modules. This is actually a 2G module here. It's the, I don't know if you can see that or not. It's the SIM 800L. So you can do, text messages with it. And if my alarm ever triggered, it'd send a text message to to our phones and say, this door was open, or this window was open, or whatever. Anyway, so I think that's completely fried now, because it doesn't, you try to connect to the network and it won't connect. And I have T-Mobile service. They actually still have 2G. They're supposed to get rid of it. I think it's either 2024 or 2025. So it's going to be good for about maybe 1 year. I had another, and actually they talked about doing that, I think, as far back as 2015. Anyway, so I had another module. This is a 3G module, but they kind of skipped over 3G. That was the SIM 5320A. And that actually, the 800L is so simple, it didn't have GPS. The other modules actually have GPS, as well as, a network connection to whoever your internet provider is, but or cell phone service provider. Anyway, so I think I'm going to go. I actually inquired about, let's see, what is it? It's category M, or narrowband IoT services. It's for another module. It's a SIM 7080G, which does the bands that T-Mobile supports, and it's I think it's $5 a month for 500 megabytes of data that you can send somewhere or receive somewhere, from somewhere. So it's pretty reasonably priced. And I think it's like $40 with shipping. Whereas these little modules, I actually got that one at Tanner's. I think it was like $9 at the time. So I don't know if anybody else has done any cell phone stuff. Has anybody? No. Yeah.
Well,
it's pretty. What's that?
well, only for work, but not data
okay.
for these IoT robot-y things.
Say that again, Carl. I'm sorry.
Well, only for work in the context of mobile devices like phones, but not so much in the context of IoT or robots. But I can talk with some danger on the radio modems involved in the SIM cards and registration and such.
Yep. Yeah. Anyway, it's fairly easy. It's, I think they were actually Hayes modem AT commands, and they're still used in these modules today. So it's just like a text string that you send it, and each of the modules has its own set of AT commands, and there's in our Arduino land, there's a tiny GSM library, and it makes it pretty easy for you to use those commands, and you just do a serial print line to the module. It's got a serial interface on it, and it implements the commands and comes back with OK if it worked, or some error message if it didn't work. So
it's amazing how persistent that protocol has been. I just threw away a PCM CIA card. Anybody remember those? It was a fax mode card with fit into a laptop. It was probably 30 years old.
Mm-hmm. Yep. Yeah, I don't know what was it? Maybe the early 80s when Hayes modems came out?
Yeah, something like that.
Yeah. Yeah, so I don't know why they choose that, but it seems like at least whoever manufactures the Sim series, I think it's a Chinese manufacturer, they've used them, even in, I think the Sim 7080G is one of their later modules, and it's still there, still being used. So, but anyway, so the other modules, they integrate a lot more. They have like this. I actually added a battery charging circuit. That's this little module, and an 18650 battery, and so it ran off just a 5-volt USB, plug, and so it was fairly easy to maintain the battery life. And when it was not transmitting, it took very little current. So, the battery it's lasted for, I think, 4 years now, and it still seems to hold a charge. So, anyway, so they're kind of neat. It's pretty easy to do. They're not too expensive. Like I said, I use this one on the house alarm, and I guess that was all I had to talk about. So.
Cool. All right. Let's see.
Carl, your video is frozen. You've got this devilish-looking grin on your face on my screen. There you go.
I see Carl moving.
All right.
Yeah.
I am frozen in time, I suppose, but anyhow, so.
Carl is definitely timeless. That's all there is to it.
Oh, I don't know if that's good or bad, but thank you anyhow.
Well, I'll leave that up to the user.
Okay. So I think we had in queue Pat, Harold, John, and then myself, Rope, and Mike. Pat, how's it going out there? You still have sun. We're dark over here by now.
Are you really?
Yeah.
So I went from being an hour the other side of you to an hour the other side now. I'm farther west.
Yeah. It's getting dark.
Okay.
Yep.
Yeah.
Here the sun will go to bed at about, 10:30 or 11 o'clock. And then we're near the western edge of the time zone, so that helps it stay light a little longer. But anyways, I had a couple things today, so I got one to present. And I'll see if I can share my screen. Can I share a tab? I've never done that. Okay. Then let's do it this way. Share the whole thing. I came across this site, this article on Tom's Hardware. Raspberry Pi mows your lawn, so you don't have to. And I haven't read through it yet. I just collected it today, and it goes through a little bit of stuff. So I thought that may be of interest to somebody.
Oh, yeah.
So I'll post that link into the chat. And then my question. I had a question for tonight, which was, has anyone ever tried to use a Raspberry Pi, like a Raspberry Pi 3 or Raspberry Pi 4, to control a motor with encoders?
I mean, without a more real-time microcontroller in between.
Yeah, like do some real-time stuff. So I didn't know if this would be possible at, frequency of whatever, a couple thousand pulses per second.
So I think the problem you're going to have with the Raspberry Pi or Linux in general, trying to do something like that is it's still non-deterministic, right? So
yeah,
motor control, and especially with encoder feedback, you need a very well-defined time period, right? So in your PID loop, you can adjust, you can throw a time element in there if you can't call it on a given period, right? So we typically tend to simplify our PID loops by calling them at a deterministic period, so that every time I look at my encoder feedback, it means the same thing, right? Because if I'm look at it one time at 40 milliseconds and then another time at 45 milliseconds, the same number of encoder counts doesn't mean the same thing.
Yeah.
Right. So that's always the problem with Linux, is you can't drill that down. You can try to make it a very high priority thread, and I think Python, being an interpreted script, is probably even worse of it than that. Although I think who was the guy in New Zealand, I think, was doing some work on a library that made it more deterministic. But that's always the challenge, right? If you can adjust for the non-deterministicness, by putting a time element into your feedback loop, so that you know how fast your motor's going, and not necessarily just looking at, oh, I had this many encoder counts over this period of time, right? Because that's got to be absolute, so that when you calculate your speed, it's the actual speed that you're running, not some speed with an offset because you weren't able to, read it at the same period.
Yeah, okay. That's sort of where I thought was heading at, where I thought I could, at the frequency for the encoder pulses, that I could count all of the pulses. But I know that trying to run something at exactly, 50 millisecond routine.
Well, I mean, even though you can count each pulse, right? How do you know how many, you're still trying to do a velocity.
Yes.
Right. So the number of counts is only going to give you a length that you've traveled. Right. So velocity is going to come of that over time. So if your time's not accurate or it varies, then your feedback's flawed as well.
Yeah, and with all the memory garbage, not garbage collection, I'm not being disparaging here. That's what we call it, garbage collection. Recovering memory that's no longer in use. All the other processes, all the refresh of the file system, all of that stuff that's going on, besides listening when 50 milliseconds goes off for you to go check your thing, that's going to mess that timing up all over the place.
Yeah.
It is.
Well,
and one of the problems I've had just running with a serial motor controller off of a Raspberry Pi running Python is, by the time I read my encoder values from the microcontroller controlling my motors into the Raspberry Pi, scan my program basically, and then write command back to the motor controller, I'm out about 80 milliseconds.
Yeah, and see, that's too slow.
That's too slow. So I'm in the process of moving everything over to, right now I'm looking at using Arduino Mega. So it'll run my motor control, but then it'll run my routine, my loop. And basically the only thing that'll be coming from the Raspberry Pi is some sensor data. And if I'm 40 milliseconds out on my sensor data, it's not going to be super critical.
Yeah, see, I offload all of my real-time tasks away from the Pi, or anything that's running under Linux. Really all I do in Linux is kind of what you would consider like the data fusion, right? So data is constantly being pumped into the Raspberry Pi, like, for instance, how fast are you going? And of course, the Raspberry Pi is telling the motor drive, the real-time system, this is how fast I want you to go. But determining those decisions and updating that value doesn't affect your motor control, right? As far as your PID loop and your feedback and understanding what your speed is.
Yes. But the problem I was having is that, so I've determined that I'm going to go to a specific point, go to a certain distance and do something. But by the time the Raspberry Pi gets the reading from the motor controller and the encoders on where it is, and then sends the info back, to stop, you've already overshot where you were because you're 80 milliseconds later.
Yeah, Pat, I think I grabbed the screen there.
Yeah.
This is one that I've used. I don't know if Doug used it as well. He might have. It's based on the 32U4, which that's used on, I forget which one, the Nano, I want to say. It's similar to the 328p
It's not enough current for my motors.
Oh, it's not. Okay. Yeah, this had two.
I'm using some Pololu 25 millimeter or 25D motors. And they have a running current. I think it goes up to a little over 2 amps.
Oh, does it? Yeah, I think this one.
And I'm running basically 2 motors in parallel.
Oh, you are? Yeah. Yeah, I think this one says it's good to 1.8 amps, but
I'm running left motors and right motors in parallel.
Yep.
Well, there's other, there's other motor drives. One thing I think that has been successfully done from a Raspberry Pi is using the timer chip. It's an I2C chip. I forget the number on it now, but you can get the little boards that have 16 channels. So basically you can plug like 16 servos into it, and then you control it over the I2C bus. I used that approach like on Turd, and I control the PID through the servo output, right? And the motor drive I have actually takes, a servo input. Now that's not a closed loop because I'm not doing actually motor control through it because I'm not reading the encoders directly back into the Pi. On that particular robot, it's more about how far have you gone than really how fast you're going. So I think that's been successfully done, but still reading, getting the accurate velocity is the real trick.
Yeah, I'm having much better luck, I think, with the Arduino getting a velocity. And what I'm looking to do now is just to, like for the Robo Columbus contest, is to offload my camera stuff to a Raspberry Pi and leave everything else into the microcontroller. So my arbitrator and everything else will be in the microcontroller.
I usually run my arbitration on the Pi or on the higher level functionality. But that's really not that's not a heavy CPU draw.
I don't think it is on the microcontroller either.
Yeah.
So basically, the Pi would be used to give me basically for my time of flight camera, for OpenCV or whatever, to detect an orange cone, that sort of stuff, and then just feed back a very minimal string back to the Arduino. That's what I'm hoping for, to try to get a little bit of luck and get rid of some of the problems I've been having with the communication back and forth.
Well, Pat, I will say that I have used that board that Ray was telling you about, and but there are other options of boards. That one is really nice because it has a lot of little features in it that like it has some voltage shifters you can use, and communication with the Pi is pretty easy. But there are other ones where you can just, all it is essentially an ARM chip or an 8-bit processor that, is used by the Pi. You communicate usually by I2C to it. And there's several boards like that. This one from Polo, like I said, if you can use those motor drivers, that works well. But, it's also, you don't have to use those motor drivers. I mean, you could put a more powerful motor driver on the side and use that. Or you can take the approach that Scott was talking about with one that uses, you just feed it a servo value. In his case, Scott, you were talking about just using the servo breakout board to set the motor value. You weren't really looking at the encoder, but there's no reason. There's no reason why you can't use the I2C bus on the assistant processor. I don't know what was that one.
But you're not. It's still not going to be closed loop, though, right? If you're driving that from the Pi. Just like Pat's talking about, even if you can get, accurate speed data, like for instance, you offloaded, like Pat's talking about, to Arduino or some real-time platform. Right. Now you have the latency problem that Pat's referring to, where you're looking at data that's at some point in the past, right? Because depending on your communication mechanism, from your real-time system to, like, say, for your Pi in this case, you got to account for that lag, right?
Scott, what I mean is the speed. Let's say you're trying to maintain some sort of speed, and you also want to know where you are, okay? You can do that all on the Arduino or the ARM chip. You can do that all, and you only talk back to your Pi if the Pi says, okay, when you get 100 yards, stop. Well, I mean, you can even feed that. What I'm trying to say is it depends on what you want.
But you're talking about a distance-based algorithm versus a speed-based, right? So you're saying...
No, or speed. Otherwise, the speed would be run on the smaller processor, okay?
Right.
If you said, you send from the Pi, you say, I want you to go 15 inches per second or whatever, okay? And so that guy's just going to run at 15 inches per second. You know what I mean? He's just going to loop through his loop and do that. Now the question so you don't have, and it's your communication back to the Pi doesn't have to be real heavy. It just, it's like, okay, the Pi says, my GPS is saying that you're going in the wrong direction. I want you to turn left or something. Well, you just turn, you don't really care if it's perfectly timed,
Well,
So, I mean, I think, but you can't, what I'm saying, Scott, is all of those low level things that you normally do without the Pi, you let it do that without the Pi. The only time you bring the Pi in is when you want something that only the Pi can do, to like analyze a picture. Or
That's what I'm looking to do. Is analyze the picture, spit the results out every 50 milliseconds, and let the Arduino do the control of the robot.
Right. Yeah.
Well, that's the same way I work mine, right? But it's just a matter of how you split up that logic, right? Because you basically have a distributed platform, right? You have processing going on in more than one place.
Yeah.
And where that processing, what task each device handles, is really platform dependent. I prefer to have my individual devices, like for instance, my motor drive is a completely independent device, right? All it's told is run at this speed, okay? And it handles the PID algorithm, it handles, running at that speed. So at that point, the Pi doesn't have to worry about anything but telling the drive what speed it wants it to run. Right. And once I get up to the Pi level, it doesn't care about 15 meters per second or whatever. It says it starts its calculation by saying, okay, I need to run 100 yards at this heading to get to the GPS coordinate, right? So it's always calculating, and that's straight from David Anderson's, some of the presentations that he did. That's basically the same approach. So he's constantly updating his target versus his current position. And that's what the Raspberry Pi is doing, right? Because that's a lot of trig, that's a lot of, cosine, cotangent. And then once you're calculating the heading and distance to a GPS coordinate, then the math gets even more complex, right? That's not something you want to do on an Arduino, right? That's something better suited for a Pi.
Well, I don't know. I would even argue that running a GPS, that's what if you have something like a Teensy going for you, that's,
I'm talking about using the GPS data, not necessarily collecting it, right?
No,
so now you're at a higher level.
Yeah, but you only want two things, I think. You want to know the distance, and you want to know the heading versus, I always get this right, is it the bearing? Otherwise, you want to know how far off you are. Okay. Right. The direction. That's all you need to know. Yeah, and all of that can be done in something like a Teensy without any problem. The thing that you can't do in a Teensy, or at least not that I know how to do, is I can't do an AI model. That's the definite barrier. So, but the only piece of information that I want is, do you see the cone? And where is it? Is it to the left? Is it straight, or is it to the right? That's all you need. All the Pi has to do is tell me, yep, I see the cone and it's to the left. And
my thing is, just give me an X coordinate.
Then the Teensy just says, okay, I got to turn right, towards the cone or whatever. But I can't do that AI model on the Teensy that I know of. Now, I'm not saying, there's so many things that you can do that I can't do, but for me, it's much easier to run the Pi to do that. Now, I'd like to get, go ahead.
Suggesting that a lot of the higher level, calculations or logic because you're kind of looking at a very simplistic term though, Doug, because you're only talking about the GPS coordinate, right? But in reality, you have an algorithm running that's trying to avoid obstacles. So in order to do that, you have to read sensor data, or you have to have sensor data available, right?
But I still think the Teensy can do that.
Well, but it's like I said, it's just a matter of platform, right? And what makes sense in the architecture of your software.
Yeah.
So you have a different approach than I do. I like my approach.
You're more successful. You're more successful. So, but I'm just going to say that I don't think,
I'm not saying that it can't be done. It's just a matter of how and where you have to share information and how information is really segmented.
Yeah.
And that, again, that's, based on everybody's platform and what makes sense in your own head, right? Because you're the one that's programming it and working on it.
Mm-hmm.
It's got to make sense to you for you to really be able to find your way around and troubleshoot things.
Yeah.
And I think that's why, if you go back to, we had the one meeting, ask the experts, right? And one of the questions was, do you like to use off-the-shelf stuff or DIY? And I think me and David and Ted, we all said DIY because that's what makes sense to us. That's what, the logic that we understand, instead of trying to debug someone else's code or understand what they did. Really, you're just charged with, writing or, figuring out why what you wrote doesn't work, right?
Right.
And I think that's kind of the same thing.
Mm-hmm.
So it's not a right way or wrong way, it's just a different way. That makes sense based on, the hardware that and the tools you like to use. That's a lot of what I've seen even in professional engineers. They want to, they know a particular tool or a particular chip really well, and they want to drive every project towards that.
Right.
But not every project needs, a cold fire, chip or whatever the case is, right? So you just have to kind of temper that a little bit and say, well, what makes sense here?
I guess when I say teensy, I don't mean teensy. That's what I use because it's easy. But any ARM chip, anything that's fast.
Yeah. Well, there's a lot to be said for easy.
Yeah. And it might even be, the new Arduino R4, Uno R4, that might even be easier because it might bring with the party some simplicity. Well, if you're using a Pi, you're still going to be fighting. This is 3.5 volts and this is 5 volts, 3.3 versus 5. So if you're using a Teensy, you're going 3.3 everywhere. Okay. And that can
more
kind
difficult now because a lot of components are going to 1.8.
Yep.
Like that time of flight sensor, its I/O is all 1.8.
Yeah, I know. I hear you, Scott. That's why that's when you buy a module that has all of that taken care for you, and you're only dealing with 3.3 or 5. That's Pololu. That's what Pololu and Adafruit sell. They sell a 1.8 part that's got level shifters and a regulator on it.
Well, you probably see it there.
Yeah.
This has got its own little level shifter on it, and the way the guy that designed it originally set it up is there's some little 0 ohm jumpers on there.
Yeah.
So you can actually change it. This is set up for 3.3 volt input, and then all the sensors run on 1.8.
Yeah.
But the way it's configured is you can change it to 5 volt input if you want. So the chip itself will go 5 volt to 1.8.
Mm-hmm.
So that part of it was pretty nice. The rest of the design was really horrible, but they got that one right.
Yeah. Yeah. So, Scott, Pat, are you confused yet?
No, actually, that's why I like coming in on these meetings, because you guys give me a lot of ideas and how to do things, how to look at it differently.
Yeah.
And I may have a couple ideas that maybe I won't port everything over and just take what I've got and scale it right back.
Right. Yeah.
Let the motor controller do what the motor controller has to do, and let the higher level stuff do what the higher level stuff has to do, as opposed to trying to merge everything sort of together.
Yeah. So I kind of, one of the things that for me, that I kind of know where I'm going to put it is if it needs a USB port, it goes on the Pi. If it doesn't have a USB port, it doesn't go on the Pi. Okay. And likewise, like Ray's messed with the Maxi bit or whatever it is. What is Maxi dock, right?
Oh yeah, Max Dock.
Max dock. Yeah, and the Maxi bit and the HC7 camera. Isn't that it? The camera, the open
OpenMD-H7.
Yeah. All of those. If you're going to open CV, that's the way to go, and that way you don't need a Pi. But if you're going to if you're going to go to Oak D Lite, that's got a USB port, so you've got to have a Pi or a Ladder or a Panda. But I haven't gone that far yet.
That's why I tend to like the Pis as well, because you can put a hub on them, and you can expand them to as many USB ports as you want.
Yeah, no, just within the power limits.
You can use a powered hub.
Yeah, but okay, that'll work.
Well, I've been using a powered hub, and then I've got my GPS communicating over USB, and I've got that is working through a little Adafruit trinket.
Yeah.
So it does the serial communication to the GPS, and then it spits out over USB. It spits out data to the Pi.
Yeah.
My motor controller is USB connected to the Pi.
Mm-hmm. Yeah, the reason I like the OD Lite, it's very simple to use once you figure it out, and the other thing about it is that it works real well with RoboFlow. You can get your models pretty well done on RoboFlow. And the other thing about it is it's got the Movint chip in there, so it's actually pretty darn fast. And plus I've got one. That last one is probably...
Got a great deal on it in Kickstarter, right?
Yeah. So anyway, that's...
Like I said, I enjoy these meetings because you find out a lot of different information and advice from people, and none of it is wrong. It's all very useful, and it gives me a good idea to look at something from a different perspective.
Yeah.
Mm-hmm.
Thanks, guys.
Yeah.
Who's next? Is it Harold?
I think Harold's next.
Harold is next. Yeah.
Wow. Hold on. I need to go get ready for my close-up. I've been being protected over here. Me, StreamerBot, .NET, coders doing weird things. Not a happy camper at the moment. But it's got nothing to do with stuff I gotta say. Let me go find what it is I want to say. I did find it. I had it here just moments ago. See how that works.
Yeah.
I do it in All right. Got a few things. One, I think you can see my monitor over here, right? Monitor for a little bit.
Off to the corner. Yeah.
Okay. What I'm showing you there is I'm going to put the link in the thing. I went to this. Where are they? Well, but I know where that is. Chat.
So I can see the monitor, but I can't read what's on it.
Hey, you can't read what's on it. I went to the Vintage Computer Festival Southwest. That was on the 24th. I haven't been able to talk to you fine gentlemen here for a couple of weeks in all seriousness. And it was fantastic. I'm also going to tell you that there was a couple of interesting things there. I got to meet, I met in person, shook his hand, 8-bit guy, if you know who that is, David Murray. He has a YouTube channel. He refurbishes and repairs and builds, believe it or not. He refurbishes and repairs old robots, does history things. He actually did a drive around Texas as a 3 or 4 parter of all the great tech that no longer exists, because he went to buildings and shot empty buildings where the tech was, and that was kind of fun. Took him a little bit. We lamented about Tanner's a little bit, of course, because that's how it happened. The Southwest show itself was pretty amazing. I got to see some real live core memory that did work. So that was pretty cool. There are other people doing all sorts of things. I got a business card from a lady that does nibbles and bites. On the back of it is some assembly language code that you could put onto a Commodore that would actually do something. I mean, that's her business card. Lots of fun stuff on that. There were a couple of things along with it. Let me find the other YouTube channel I care about.
Did you mean the core memory still works?
Yes.
Cool.
And
Yeah.
I could take you to an elevator job in downtown Dallas that the dispatch system is running on 12K of magnetic core memory right now. Every year we have to go down there, or about every year. You load the program into it through a paper tape reader.
Oh, fantastic.
And this is a folding paper tape, not one on reels. We had to have it replicated a while back because it was getting so wore out.
That doesn't catch on anything. It doesn't at all with the folds.
Well, there's a little bucket on the tape reader where it's supposed to fold up into. But if it gets out of the bucket, but the program's still loading, then you just let it go all over the floor and you pick it up and you fold it up later. Because it's very fickle. This thing has a set of dip switches that you actually have to load the registers manually. Each dip, it's a 12 or 14-bit system. So you load the address into it and you hit the load button, and then you flip the switches and then you load the data into it. And you basically put this thing in kind of a bootloader mode. And then the tape starts running through the tape reader. And its technology is out of the 70s. And it's still running today, believe it or not.
That's awesome. Well, this place had a big old conference room full of all that stuff. Some of it was actually new because they're building things. In fact, 8-bit guy has his from Electech. They built a brand new Commodore computer. They call it the Commander 16. It's running the Commodore kernel, but it's not Commodore 64 compatible. So they do some extra things to it and that kind of stuff. Thank you. Thank you very much.
You're so welcome.
Thank you.
Your kindness really gives me a charge.
That's one of the robots.
By the way, you have one new notification. When you see the yellow light ring on your device, it means you have a notification or message. Just say, read my notifications.
Computer, stop listening. All right. So,
hey Scott, is that elevator Y2K certified?
I'm going to say no.
Luckily, it's totally unaware of what year it is.
Yeah, it doesn't have a clue.
I was going to say, you'd probably be doing us a favor by telling us which building it in, and then that way we can all avoid it.
They had sessions there on basic electronics, some other things going on. It turns out that there are some shysters out there that they're selling fake chips. They're resurfacing the top of them, calling them something else, and charging a premium price for the fake chip. And all these people were lamenting some of that because they're looking for sometimes a very specific chip from a very specific era because of timings and whatnot they have on the boards. And so there were some folks timing that. But one a very interesting lady, I'm putting a link in the chat now. I do not remember her name, and I did not get to go see it live. Rebecca Hyman's, I think that's her name. She says how I reversed engineered the Atari 2600 because I was broke and didn't have a job. So what this lady did, it's an hour-long thing, and you can speak through it if you want to. But I found that she had. I go, okay, let's just see the thing because it's up on the video, and I missed it, and it might be cool. So I did this. She ends up telling how she reverse engineered the Atari 2600. Built a custom card she slapped into an Apple II so she could read and write the ROM chips and update the ROM in real time to change colors of things on screen. And as she did that, was doing a demo, that got her a job writing something like Bard's 3 and a few other notable titles and stuff. And not to mention that when they ask her, what's your development environment? Well, my card I built here, my Apple II and whatever. And they go, what, you didn't get something from Atari? No, I just built this. Can you build more? And that kind of thing. Very, very interesting talk on the kind of thing on there. And so if you go look at the channel and those two links I sent you, that second link, if you actually go look at that channel, there's a 2-hour session I was in talking about YouTube and makers and that kind of stuff. And I thought they were... I thought it was a really good session, and also felt that I found some peers. Let's show the good with the bad, and you don't have to be all perfect, and all these kind of things. It maybe come to the realization that if I actually want to be on a YouTube, I have to decide that I want to be a filmmaker or not. Because if you don't want to be a filmmaker, you might as well not even try. They're saying it takes them who do it and have hundreds of thousands of followers, some of them, an hour of editing time gets them 1 minute of video. That's what they put it in at. So those 20-minute videos, half a week work, easy. A full-time work. So I'm like, okay, that makes me reset some of my expectations and things. So, but there was that, and I'm doing a little chronological order on this. Then I didn't see you 1 week because I was in Topeka doing things, but that doesn't matter that much. But after it's all said and done, and I came back on July 6th at 10 a.m. in the morning, I have now been re-upped as a Microsoft MVP. So much to the chagrin of everybody on this channel, you get to listen to me blather on about Microsoft for another year, whether you want to or not. Okay.
Congratulations, dude.
Thank you very much. I did not expect to do it. And I want to say thanks to people like you and everybody in this user group. My interaction with the community and folks and having attending these things and being, I don't know, accepted, but I don't know what accepted actually means. But the fact that I'm here every week and you folks are here and we're listening, we're talking about, we're doing these things, that helps me a lot. And thank you everybody very much for all that. I sincerely mean that. What else? I've got one of these. You may ask yourself, what is one of those? I got this idea that we have all these sensors, and I got, thanks to Murray, I've got me an optical flow sensor. I've got me a point time of flight laser, and I got the 8x8 thing I mentioned earlier tonight, all from Pimoroni. And I have a couple other I got a BO 085 and a BO 055, and those are all sensors, and I want to be able to play with them. So, but holding a thing plugged in, trying to get it on the board to figure out the stuff is kind of a problem. So I started designing one of these, and that's a 100 millimeter cube with plenty of open spaces. In this case, this is for the flow sensor, and I'm designing some holes in it so I can change the height of it off of it by some of their specifications, and so I can leave that set somewhere. And then I can't do very much about the motion of the earth. I can do a little bit about the vibration of the air conditioner right above my head here, but I can't do much. But that's about as steady as I'm going to be able to get it. And I've got an idea that I've got this base saved in Fusion, so when I get my next center, we'll change how the thing plugs in on it, print off another one, and then we'll just build up these things over time. I think it's pretty cool. It may be too thick, or maybe a little too thick. We're going to change this over time, but this is something I'm going to build when I get these sensors, so we can just play with the thing. And at the very least, if you got an MPU 6050, that's where I got the idea from. Believe it or not, I have one set over here. I had a blue thing sitting over here that gave me the idea, and it was just too small to be able to strap that into the blue thing, set it there on a flat thing, do the calibration so you get your offsets and that kind of stuff, so you can set it so you're not having to worry about something is going to move on your do whatever as you're setting your offsets. So that's kind of what I got coming. In fact, tomorrow night we'll be messing around with that optical flow sensor, and we'll see. I haven't even powered it up yet. They're in a box there that came from overseas. I was doing other things, so we're gonna see if it works. Hopefully it does. Be a short stream. If it doesn't, well, who knows about that. Anyway, there's that. The VCF. Also, I just mentioned the 055 and the 085. I've been doing a bunch of reading on those because I know that Chris was his name, right? That he's done a lot of work on them, and he liked the 085. He liked the 055 over the 085. After I've done the amount of research, I found that they're the exact same hardware as far as the IMU is concerned. The only difference is the firmware. Somebody's got a different opinion of what the firmware is. So, all right, I've got two different opinions on how things should go now, right? And we're going to put them in one of these. I'm going to make one of these things up for them, and we're going to put them in there and see what we can see. And one of the things I found, especially for you, Carl, you know how they kind of get out of calibration and all that kind of stuff?
Yeah.
I can't point to where I saw it. I should have took a note of it going. And you may already, and if you already know this, okay, never mind. But I just figured I'd tell you. I was going through some of the Adafruit thing and some other things. Those things are affected by high frequency signals going next to them. So if you got any of that going on anywhere close, and I don't know what high frequency means, it's going to throw those things off after a while. At least that's all the notes I found. So you're a smart fellow, Carl. I figure you already knew that, but I want to make sure.
Well, I mean, the devil's in the details. So I think the question is it high frequency mechanical vibrations, or is it high frequency conducting or radiating?
The stuff I read was electrical signals. Like if you've got a high speed bus or something like that going somewhere new.
Carl? Yeah, that might, you might look at running your robot with and without your NeoPixels. Turn off your NeoPixels.
Yeah.
And see if that does anything.
Well, the thing I keep going back to is that the drift was introduced. Nothing else changed except for physical motion of the robot.
Yeah.
So
all I know is I found a data point, whether it's useful or not.
No, it's cool. And the thing I also remember hearing was that there was kind of like a reason for the 055 versus 85 was one of application. So the firmware was designed for different use case.
Yeah. So I got one of each. In the process of having parts show up, I want to tear apart at least one, if not both, my spare printer I bought and my oldest printer probably, and turn it into another robot for next year. And I've got motors coming, I've got encoders coming, and I am being very ambitious here because because of the talk that you guys were just having about motor controllers. I don't want to spend $100 for a robocall. That's the 2x15s, the 2x7s. They're like $80, $100 a pop.
Yep.
They are fantastic, by the way. If you have the money, just buy it and be done. All right, but I don't want to spend the money. One, and I found on AliExpress a bunch of those TV6212 FNGs. Those ones that are the MOSFET motor controllers that do like 1.2, 1.3 sustained up to 3 amps per motor. Small, light, all that kind of thing. I'm getting a bucket because every time I go to Micro, there's a standard order. They don't know this, but I go to Micro Center and I get a Pico W. Somehow that just always falls in my basket every time I go to Micro Center. And so I'm getting a bucket full of them over here. And my thought was that I could, after I get that designed up, I've never built my own a functioning one, by the way, on PCB. I built one back in high school that by hand with the pen and the etch and the light, and it was fun, but it was a mess. And it didn't really work. So I figured what I would do is once I've got this prototyped up in the way I want it to be, make sure I can control stuff, then I will, and I'm probably looking for recommendations for decent, cheap, not necessarily fast PCB. Like I'm figuring a PCB way or JLC, JCL. You know, was it Altima?
Yeah, we've had some somewhere back in the early COVID day notes. I think we got some lists of those various places.
Yeah,
shops.
One of those. I'm not married to any of them, so it didn't really matter to me at the point. But then what I would do is I'd build a board just for the connections. Like we'd put in some headers so we could pop in the 2040W and the motor controller itself. That'll already be pre-wired for all the things and have one little board that would control 2 motors and plug in the power wires. So make it nice and tidy to be able to just mount those things. And if you needed to replace a 2040 because you let the smoke out or whatever, you could do that. And then make it then turn that into a software exercise to write the cool things that I need to use off the roboclaw. Not necessarily. The idea being is set them up to be able to set themselves up to the auto pid per wheel, and then be able to send them some kind of information over some mechanism, which I haven't figured out yet. I2C, serial something or another. You know, basically wheel 1 speed, wheel 2 speed, that kind of stuff. Very much what you folks were just talking about on what you need to do. And I thought that might be a kind of a neat little project. And since I don't have any or very many external components, other than things that are already prepackaged to slide in, I thought that might be, I mean, it sounds like a big thing to me, but it sounds like a doable thing without having to worry about, did I get the capacitor the right size in the wrong way as I'm surface mounting it on the thing and all the other junk that matters with that. That's kind of why I was trying to avoid.
But in the meantime, if you're trying to get a platform going, you might want to just buy a RoboClaw and use it.
I've got one. I don't want to buy a second one. But you know what I'm saying? You know, I think it's going to be fun to do, and I think I'm going to start with just breadboards and do it. And I've got some of these, and I can make them hard code. I got a bucket full of these perma-protos coming in here, so we're going to go from the breadboard that I think works to one of these perma-proto things, so we can actually use it, and then we'll worry about the rest of the stuff. That's kind of the idea. That was my thought.
They do. Well, you probably know, but like you can do, like as far as a motion profile, you can do an acceleration to a velocity, a deacceleration to a position, and that's fairly complex. So you could.
That is.
Yeah.
I figured I would start with being able to have them pit tune the motor, which I think is probably going to be complex, at least a little bit. And then be able to, with the protocol, be able to give us the commands that says motor 1 go this fast, motor 2 go this fast. And then, and then once that's done, I'll call that what we call in the biz an MVP. right? That just, I think that's a doable level. There's just not that I think I'm going to do everything that robocall is going to do. No. We're going to do the very, very minimum to make this useful to me. And that's, and that right there would be useful, because then at that point, with this robot I'm building and the optical flow sensor and the IMUs and all those sorts of things, and my 8x8 LiDAR thing going on there, I should have me some kind of, I don't know, Franken robot or something going on there. And I've got lots of parts and pieces to make platforms that have been sitting over here in the back over here, most of which you've seen over the time, that I can utilize. All this stuff's been sitting around the shop forever, and we'll make a robot of it and see if we can't bring that to competition. It's going to be the next indoor competition. I won't be ready for November or anything to do anything crazy like that. But yeah, so I've got all those things ordered, and we're going to play with the things, and that's kind of the stuff I got going. And if anybody wants to, because I've gotten a lot of knowledge out of you folks, and figuring things out and listening to things, and so if anybody's got ideas as I go along, I'm just kind of throwing it out there about what I'll be doing. And at the moment, the frustration level you see in me, if you see any frustration at all, it's because friggin' StreamerBot can't do MQTT like it said, because it doesn't have the right namespace to go do what it's supposed to do, even though it said it did it. And everything else is working great, including the Pi 400 that I've got a MQTT broker on for the household that works awesome right now. But I can't get my Mr. Big Head talking to my StreamerBot. How's all that?
Sounds like vaporware.
It currently is. I am so disgusted. I am so disgusted. We've come so close and figured out so much, knowing that part of this was a known good, and the known good sucks. And that's my, kind and gentle words for it. So, yeah. And the other thing is, in case you're wondering, in case everybody ever asks you what is the most used language in programming, the answer is profanity. That's all there is to it.
There you go.
Hey, Kareem, I had a question. I know there's RoboClaw, and I know Rev Robotics has a controller. Does GoBuilda make their own controller equivalent to like a RoboClaw?
I don't know the answer to that. I know that they recently came out with a new control system of some sort, but it's not legal in our competition, so I never bothered to go and look at it. So
yeah,
I don't know if they have anything like that. Besides
Rev and RoboClaw, is there any other competitors to those, to those products, or that you know of?
Well, there's tons of motor controllers out there.
But they can do the same sort of motion profiles that the RoboClaw and the Rev controller does, or?
Well, there's O-Drive for.
O-Drive.
Yeah.
Yeah. Isn't that what Bruton uses all the time? Those O-Drive controllers?
I think he has used them. I don't know if he uses them regularly, but I think he has used them.
Your suggestions keep getting more expensive.
Yeah, that's true.
So is O-Drive much more expensive?
Have I mentioned I'm in the course of building some, so it's gonna.
When are we gonna get a money printing robot? That's what we're short on.
Yeah, that's a pretty large rabbit hole, that Harold, that you're about to jump into. So
I totally understand that, and in fact, I was just. Here's the only reason I'm really doing that is because this robot that I was envisioning in my head here, I have 4 motors, 4 PIDs that I've got to do. I did not want to gang up both motors on each side, because I could do that, because it will be skid steer, all that kind of stuff. But I'm a high I guy. But my high C guy's kicking in and tell me if I don't do a PID loop on each one of my motors, and I tell the motors to go at X speed, how do I know that both pairs the pair of motors actually going at the speed I think it's going at. I want them both going that speed. I don't want one going a little faster or not, that kind of thing. And that's what's bugging me. I got a RoboClaw now. I could throw it on there, put it on there, make one a follower and the second one just, and the first one the PID controlled and the second one a follower off the first one and pair them up like that. I could do that now. But there's something in me that says you can do better than that. That's kind of the way that is. And yes, it's a rabbit hole, and I know. And that's why I said I was very ambitious. I can even admit that.
Hey, Doug?
But it sounds like no, actually.
Well, if you got off-the-shelf hardware, I would say get it working first, and that's like your reference, right? And how you know that you're even using it right. And get that squared away before you jump down into doing
I'll go,
custom builds.
That's a good idea. What I can do.
Hello, this is Jim in Calgary.
What now? Yeah, Jim,
you got your microphone working.
How you doing, Jim?
Yeah, it's Jim in Calgary. Harold, I second the emotions.
By the way, everybody, Jim is
frustration. Hang on.
Jim is one of my most frequent streamers, so he's seen almost all that stuff I was describing. He's one of my most frequent followers on my stream.
Harold, warts and all, but I agree with the streamer bot frustrations, but there are workarounds, and we can discuss that on Discord.
Oh, certainly. I just found that streamer bot thing. I've gotten a little bit closer, but it's still messing up crazy. And
hey, I may be closer than you. We can collab, okay?
Fantastic. I'm always good with that. I'm always good with it. You know how that works.
I enjoy the robotics conversation, guys. Thank you.
Cool. And so, yeah, and Jim's seen a lot of this, and he's been right there in the trenches, and he's helped out. In fact, he gave me an idea or two the last couple of weeks on some of this stuff, and we're poking around on it.
Doug Dotson, didn't you work with on your telepresence robot? Didn't you design, or with Murray, you designed a motor controller?
I did not design a motor controller. I used the LH295, whatever that is.
Oh, okay.
But what I'm talking about, though, is just not a thing that drives an H-bridge where I can tell it to go to speed. I'm looking at something that drives the H-bridge, receives the Hall effect, the quadrature stuff coming back to it, and adjust all that stuff as it needs to be so I can give it, literally send it a speed and a forward or reverse. Yeah.
Now, speaking of Murray, a name we haven't talked about lately, he was writing his own ROS, which is sort of what it sounds like Harold's doing.
I don't want to do that, but it does sound like it, sort of. I want little firmware things. Because I'm a big fan, I don't know if Ray's still on here, I'm a big fan of Ray's idea of let's have an encapsulated thing that does what it does really, really good. And I'll tell it what I want it to do, and then let it do it until I want it to do something else.
Yeah.
And let it handle all of that stuff.
Yep. It's pretty handy.
Yeah.
Definitely simplifies things. You just say, I want to go at this speed. I want to ramp up to this, this is the ramp I want for it.
Here's the ramp. Or sometimes in some of the vernacular they call it easing. We have an easing function that so we ease into a thing or ease out of a thing. That's what they talk about it in graphics a lot. When you're moving a thing and it goes right, that kind of stuff that eases in, eases out. So yeah. And then you just made it harder. You just made it harder, Ray.
Yeah, there's believe it or not, I accidentally fried one of my RoboClaws, and the warranty is great. They didn't have any issue. They sent me another one, and there's a thing called it's got some fairly large capacitors on the supply, and if your if your wires are too long from your battery to the unit, you can get into a situation. It affects the ground. It's called a DIDT, ground bounce. As you're quickly charging those caps up, it can basically put a spike on the ground, and that spike can, if it's large enough, can destroy other components on the board. So there's, they said to basically charge it up through, create an RC charge cable is what they called it. And apparently they sell them, they're like for, radio controlled stuff. And it has a low value resistor in it. So it basically slows the rate at which
flattens it out.
Yeah, those capacitors are allowed to charge and reduces the DIDT spike on the ground. And so there's all kinds of weird things, that even as you turn it off, they recommended putting a diode across your power switch, because if your motors are still running and you just you're going to get an inductive kick off the motors, and that's going to try to make it back to the battery. But if your switch is open, it can't go anywhere, so that voltage spike gets pretty high. And so there's all kinds of weird things that can go on with high currents and tight loops and that kind of stuff.
I want to say I will take the group suggestion. I've got my RoboCrawl and my first robots over here. We're going to pick it up, and what we're going to do is we're going to pair the wheels and have one of the set of the wheels be a follower and the other one be the actual pit thing that we carry on each side of it. Yep. We'll start. Yeah.
Yep.
I still got all the parts coming though. I'm just saying. I got a pile of Pico W's around here.
Yeah, I'd be curious to see your progress. I wish you luck with that. It is not trivial.
Thank you very much.
Okay, cool. I think we got next John and then me, unless someone else came in before the queue and has anything else, like Doug or Kareem.
Okay, in that case, I'll take it away.
So, John.
Theory, once I click on the right one, was this I found. So it's interested in the sense of cloud. Yeah.
It's not.
Oh, you're seeing it?
I'm not.
Not seeing it.
Uh-oh. Yeah, it complains. Okay. See if we can try it again.
Oh, I got another random question here. Has anybody done the latest Windows update and then you found out your SD card reader doesn't read cards anymore?
No? I'm about to do that.
I took it and it worked okay.
Huh.
Well, I haven't tried the SD card reader, so maybe it doesn't work, but.
Yeah. I don't know if there's anything like Greg, but my SD card reader doesn't work anymore.
I'll be right back.
So there's this flaw I found that's interesting because of the way it works.
John, I don't think it's showing up.
Not seeing anything.
Well, I'm on a different computer. So what I'm going to do is send you the link, Carl, and you may need to share.
Were you trying to do a presentation, John? Or?
Yeah, I'm on a different computer, and I'm going to switch back to my other computer. So, Carl, if you can share that.
Yeah.
It's an interesting claw, the way it works. It's estimated. So that's why I thought it was interesting.
So what does it use? NinjaFlex or something?
Well, it looks like it's two parts. So yeah, I'm thinking that the one part, the little rib-like thing, isn't it? So yeah, you can scroll up, or there you can see the little parts, and there's that the sort of red part looks like a hinge light. I like the fact that I was able to grip, different shapes.
Yep. Able to grip 10 times before the Ninja Flex rips, right?
All right.
So yeah, I thought that
You'd be surprised how strong Ninja Flex is. It's like one of the least likely things that we have to fail.
Seriously.
And we use it all the time.
Wow.
Yeah. We built wheels out of Ninja Flex that are running 2 years in, and showing very little signs of wear, and this stuff is hard to rip.
Oh, it is, huh? Oh, I thought it would be
it's very hard to rip. It'll do a lot of cycles too.
So does that require higher temperatures, much higher temperatures than PLA or something?
No. I'm trying to remember, probably 260, something like that.
No? Wow.
Sounds about right. The biggest problem is, though, that their printer has to have be able to basically
deal with flexible filaments, right? So it's
run through it proper. Otherwise, it jams.
Direct extruders are better, and yeah, they have to be pretty good at dealing with flexible filaments, or designed specifically for that, I would say.
Oh.
Most modern extruders are designed to do both of the direct drive type.
So yeah, I thought that was a very interesting design for the flexible claw light thing. And then the other one, Carl, if you want to pop that in, it's interesting just because it's a very well built tank light thing. It looks like. So, and it uses the relatively cheap motors. So that was the other thing that caught my eye.
Cool.
If you want to click on one or two of the little parts, you'll see the skeleton inside of it, basically. So if you go up there and then sort of tab, you'll see.
Looks very modular. A lot of screws.
Yeah, that's why I said, yeah, there we go. To me, it looks like it was well built, well designed.
So do they use somebody's pre-made track?
No, it's all three 3D printed.
Oh, it is? Huh?
Oh, yeah, but it's well designed. It looks like to me.
Yep.
See, there's the tracks. So.
Looks like some time on the printer.
Yeah, but it's well built. It's not a fly-by-night one. So that was the part that was interesting to me.
Yeah, it looks like he's put fillets in on everything, and yeah.
So if you want to place the prey, I haven't done the play, but I imagine it's the typical robot run around thing.
It's always funny to me to see tracked robots on a nice smooth surface.
Yes. Yeah, those both were well designed, the two things. So,
Very nice.
So, Harold, if you want to plant, there's the arm.
Okay, like I need another project that I get off the internet that's not going to work. Okay, let's go.
Now, the arm will work. Now, the other one, the tank, it should work.
I am being positive, folks. I'm positive it's going to suck. I'm just saying.
What could go wrong?
Literally, my track record of looking at things on the internet and doing exactly what they say and having it just work is really low. Some things do work, but not, they missed a few things, that sort of thing.
Well, we try. I would have
like that arm, though.
Can you plant the arm? That arm especially looks neat.
I found some toy that's got this like squid sharky arm things on it. It's got 3 of them for like $10, $15, something like that on Amazon. I'm like, dude, can I adapt that for a can? I don't know. We'll see.
Yeah, but like this thing I would think grab cans very well, the way it's built.
They could just reach
look at that thing.
And the fact that they use basically rope to pull it in.
Yeah.
Well, if it can pick up some sugar, that box is empty though. I'm telling you now. Yes, I've got some negativity going on. I don't mean to.
They do make 1-pound boxes of sugar too, so it's may not be that heavy.
It could be empty box.
Cool. All right. Well, thanks, John. Any others? Other finds? Nope. Okay. All right. Well, so I'll give a brief update. I'm still distracted from robots, so I thought I'd share a couple of distractions. The first is and they're both questions. So the first is, what happens when you cross a Blink LED project with Las Vegas?
Oh, that MGM Sphere?
It's a kind of rhetorical question.
That thing's amazing.
Yeah. It's, I don't know if anyone's read up on this, but talk about blinky light projects. Oh, my goodness. Apparently, the entire surface, if you haven't seen this yet, the entire surface to the outside world can project whatever you want it to project.
Yeah, somebody projected like a blinking eyeball on the thing. It was pretty creepy.
Yeah, there's the moon and blinking eyeballs, but then inside, so it's got basically a planetarium style screen overhead that's the size of 4 football fields, basically 16K resolution that claims. So anyhow, that's I
don't know if I'll be able to get in there, but I'm going in the end of September.
Yeah.
At the very least, I'm going to outside that thing.
You need to, yeah. The first 2 concerts apparently sold out. Who knows after that? But I'm sure it'll be Vegas pricing. But I'm sure it'd be quite an experience, though.
Agreed. There's the moon, and actually, if you go out and look, you can find videos of that.
Oh,
and
yeah.
The moon is turning. I think somebody can even do. They can do the Earth.
Yeah.
And I heard somebody was asking, could they do weather accurate stuff on there? And I'm like, once you got the geometry figured out, as long as you can get a picture, that should not be a thing.
Oh, they have it. For it to do what it's doing, they got the workflow in place. So
yeah,
it's just a matter of how efficient it is. Yeah. So that'd be fun for anybody in Vegas. Okay. So the second thing I have is a pop quiz, and like I mentioned, I was on a lot of airplanes the last couple of months. So because of what I was bringing back from Pittsburgh today, I read the American Airlines baggage policy for carry-on and checked baggage. So this is a pop quiz. Who thinks who can say what the policy is for a lightsaber? Is it allowed or not allowed?
I'm saying it's allowed.
Okay. Harold, well, I guess that's kind of cheating because you already did carry a lightsaber, and they explicitly said that it's allowed on carry-on bags and checked bags Although they popped the bubble, sadly it doesn't currently exist to create a real lightsaber, but you can pack one. May the force be with you. Okay.
Yeah. There's a lot of cosplay people that pack those things all the time.
No doubt, but lighter fluid, no. But lightsaber, no problem, buddy. Just come, bring it on board. Okay, which raises the next one. Huh?
Yeah, do you have to turn it on or demonstrate that it really does only light?
I don't know.
I don't know. Maybe they need to ask about the dark saber, right? Because that's even, okay. So, all right. So the next question, pop quiz: Magic 8-ball. Should that be allowed or not?
Probably not.
Not allowed.
I say no.
Liquid in it.
Too much
liquid.
I'm with Grim on that one.
It's probably considered a weapon.
You guys are too easy. Yeah, and it says for carry-on bags, they asked the 8-ball and said not so good.
Not so good.
It's okay for check bags. So I just thought it was funny that it was like called out specifically. Anyhow, that's my minimal contribution for today.
Yeah, what about lipos?
You know, they went through the standard 100-watt hour batteries talk.
Yeah.
They had a specific section on drones. I mean, there's like 150 specific items that they call out. But I happened to bring back the steam whistle for a steam whistle for a locomotive. It was like 8 or 10 pounds, and they didn't actually talk about that. But it made it through checked luggage.
You got to put that on your car?
You know, that would be cool, wouldn't it?
So your plutonium-powered lightsaber is allowed, but a lipo cell is not.
You know, it just doesn't make sense, does it?
And what's funny with the lipos, depending upon if it's secured or not, if it's built in such a way that you can't easily remove it, it's okay. But if you can easily remove it, you have to remove it and carry it separately. And whatever.
And there's limits on spares. I mean, I've talked to some of the flight attendants on that, and they talk about, if there's going to be a fire, they just want it to be someplace where they can deal with it, because it's a little harder for them to deal with stuff flaming in the baggage compartment.
Inside the fuselage.
Well, that's where they want it, in the cabin.
Yeah. So I'm assuming most of them have those little bags that you can stuff your burning lipos into, right?
Yeah, the RC people that I was talking to when I was asking that question, like, hey, do I need to get one of these battery bags, in case you catch on fire? They just kind of laughed at me, giving me a smirk. They smirked at me. So I don't know exactly what that meant, but I didn't buy one of those bags just because I'm like, I'm getting shamed from the people behind the counter at the Hobby Town store.
Hey, this is Dave. One of the things I wondered, has anybody looked at the Guinness World Record 4th of July drone show?
No.
I heard about it, but I've not seen that.
Yeah, it's like 600 some odd drones.
No, it's over 1,000.
Oh, it is 1,000? Okay. Yeah.
Yeah, it's on YouTube.
Yeah. Yeah, I wonder how many extra drones they have, because you get one that goes haywire and it crashes and takes out a few of the others, and then you've got to replace those in the image.
And the other question is, how do you control that many drones?
Yeah, that's quite a few drones.
You have some people there.
I think to answer that question, they've been having swarming algorithms for a very, very long time. And maybe they're not controlling it so much as to telling each one of them drones, you're supposed to be here in the picture next to these other drones, and if everybody lines up right, this is what you get. I don't know how error prone that is, though. I suspect lots, but maybe you can handle that.
Harold, I think you're right. If I remember right, the other morning when they were describing it, they basically said that the one drone next to the other drone talks to the two drones. There was just a association type thing. So yeah, as long as the first one behaves, then all the others basically follow.
So I'm thinking maybe what you have in how we have a graph tree of information, right? Maybe they have a graph tree of position, and every drone is a node.
Yep.
Maybe
that's basically how it works.
So Dave, what are the odds that it's not Wi-Fi? Probably.
Yeah,
Yeah.
Well, an old power Wi-Fi, maybe. As I said, they call it one to the next door.
yeah. But if you, I've got it on my other screen here, but I can't seem to paste the URL into the chat.
Let's see if we can find it.
There we go. Let me try there. There we go.
Featuring 1,002 drones.
There it is. I just pasted it in.
You did?
So, yeah.
Where was that? I forgot where it was.
It was here in Dallas.
Oh, it was in Dallas. Okay.
Yeah.
I don't see the link in the chat.
Okay. Let's try that. There we go.
Yep, they got it.
I hadn't clicked the right button.
Was that associated with some baseball event? I remember seeing like the stitching on a baseball, a sphere. And...
It wasn't Dallas. I forget which city, but it was around.
Fort Worth. Yeah, I thought it was actually in Fort Worth or near Arlington or something.
Yeah, 1,002 drones. Let's see
That's a lot of drones.
With the LED lights to flight and dazzling the crowd going. Anyhow, that's the.
I can see in a very short order those taking over all the fireworks.
Yeah.
As much as I love fireworks, and I do love me a good fireworks show, but I can see them taking over all.
Well, they were doing this with fireworks at the same time.
Were they?
Yeah. Yeah, if you look at the thing, they had fireworks there.
I do remember seeing a picture of an X-wing flying. An X-wing looked like an X-wing flying over Batu, which is the Star Wars Galaxy Edge. And basically it was a giant drone with imagine the X-wing with the motors for the drone inside it where you couldn't hardly see the motors, lifting it. And it was like a giant drone the size of whatever, flying over there. Of course, Disney had permission from itself to be able to do that. Most people can't fly a drone over Disney. So, but it looked really cool. I'm like, dude, that'd be bad. That would be bad for Bone to have that.
That's pretty cool.
That's pretty cool.
And like I said, they had fireworks at the same time.
Yeah. Good coordination, and the fireworks didn't shoot the drones out of the sky.
Well, I think they spaced them about a mile apart.
Yeah, that's probably a good idea. Well,
they're
multi-purpose. You can drop bombs on tanks, Russian tanks. You can do light displays with them. It's.
Okay, guys. So where are we? Anybody else? I know
we got rattled on pretty good today.
So I can make a brief comment about the RoboDog.
You got a moment? Oh, good.
You probably can see I've got wheels. I've got legs that are standing up. You probably, because of the resolution, can't see. I put these nails in there I can nail it into that spot, turn it, nail it into another spot with these rubber bands, kind of pull it out. Wires not yet hooked up. Next week, I hope to have the wires hooked up and it roll. I didn't quite get to that this time. You probably can see that these front legs are a little longer than the back legs, and it will be real easy to shorten them, but I'm trying to decide if I like that look or not. That was accident, because originally it was going to be 4 legs with motors like this, and then I decided to put these casters on there, and they're just taller. So it made the front be taller by several inches. But I may just leave it like that. I want to see how it rolls and see how it looks. It gives it a bit more of a bulldog look. I don't know. We'll see how it goes.
Yeah.
You can say it was intentional.
Yeah, I meant to do that.
Design feature.
So maybe next week I'll have it actually rolling. Right now it's just sitting there. The wires aren't connected to the motors.
Yeah.
But I did get the motors in their little housing here and inside this, so that was the first step. I want to make some kind of a rubber coating wire tube or something that brings that into there, but I may not do that for next week. I may just wire it up and make sure it works, and then I can always take it apart and put it inside tubing. I bought some, but it turns out it's just a little bit too big, so I got to get a smaller tubing. Doesn't fit the holes I drilled. I don't want to drill bigger holes. Like a beach sometimes. So that's all I had. Just I'm making progress.
It's cool. It's cool. Next week, rolling.
Yeah, I don't know if you can see behind me that white thing there, but that's been eating up my time. That's a telescope mount.
Yeah.
I'm finally getting my astrophotography stuff going too, so it's been eating up some of my robot time.
So are you looking for the habitable planets for NASA?
I can't see anything that good, but I found out that you can actually, in a light polluted city like Fort Worth, with a DSLR camera, take pictures of things that you didn't think you could take pictures of. Now, they're not going to be big like a Hubble picture, but you can actually see what it is, and so I'm wanting to try it.
I have a friend by the name of Tim Shue that basically does that out of his backyard, and he literally takes exposures over hours.
Yeah.
This is not a direct thing, so you got to get it pointing in the right place and have all that mechanism to keep tracking it, right?
Yeah.
And then he takes a bunch of pictures, and then after he gets all those pictures, he brings them down and then processes them or run them through some filters and some computational thing to be able to shove all of that data to get them, because you only get so much light.
Right. They call that stacking, where you take 100 pictures and you turn them into one.
Turn them into one.
You kind of average all the.
He does that. He takes some very, very, very amazing pictures from his backyard, and he lives up and down.
The problem I'm going to have, and I say it's the problem I'm going to have. I've had a lot of problems with that right there already. But after you do that stacking and get all those pictures down to one, you still can't really tell what you're looking at. You got to go into Photoshop and enhance the picture, and that's where it's going to kill me, because I'm not thinking I'm going to enjoy that, but we'll see.
It's cool.
Not robot-y, but it's been eating up my time.
It's still cool, you know. Actually, technically, I'll tell you it might be, because the time you put all the actuators and things you need to be on that robot to track the stars that go across, you got motors. You're tracking X, Y, and Z on that thing. It's a robot, dude.
Yeah, somebody else built that robot. It's already built right there.
That's okay.
I just got to control it. So I have to configure a computer with all the software that's going to manage all that.
Talking about pictures of stars and what have you, I haven't actually tried it, but there was an article about the AI that's in these
the camera phones?
Camera phones, where you take a picture of the moon and it says, oh, well, that's the moon, and therefore, here's a picture of it for you.
Yeah. I question myself whether I'm being stupid and spending all this money and time on a picture that's not going to be anywhere near as good as thousands of them you can get on the internet, but it will be the one I took.
Yeah.
And you enjoy it. So that's what matters at the end of the day.
Yeah. I never thought I could do it inside of a city until I saw somebody else doing it. So then I wanted to do it. And I pared my expectations down from a $10,000 rig to a $1,500 rig, which is still way too much money for something that's not going to get me all that much other than enjoyment.
Yeah.
I guess it was, wasn't it Steve Jobs says, look around, you see all these buildings, all the things, all the stuff, the roads, all that kind of stuff. It was all built by people no smarter than you. They just had a priority to get something done.
Yep.
And I firmly believe that. I don't think it's anybody's technically, there's other stuff, maybe uneducated. But I don't think anybody's any less smart than anybody else. Just what it is you want to do.
So we're not so much dumb as lazy.
I'm lazy.
There you go, Kareem. Thank you. I didn't have to do that.
If it was so much effort to agree, I'd agree with you.
If I wasn't lazy, those wires would be connected, and you can see that we roll. But I got busy playing some stupid game today instead. I needed some time off from thinking.
All right, guys.
I'm out of here.
Good long meeting. Anything else tonight? I'm seeing some waves. I got to get going too. All right.
Have a good night, y'all.
Catch y'all next week. Take care.
Thank you.